10 identical cubical blocks, each of mass 200 gram and side 40 centimeter are lying on the horizontal surface. What is the work done in placing them all one over the other? In the previous problem, we observed a block is rolled a number of times and work done is 0. But here, 10 blocks we want to place one over the other and interested to calculate the total work done. So let us consider a scattered blocks. These are all blocks scattered on the ground, identical blocks. Our aim, suppose if I say this is 1, 2, 3, etc. We want to keep 2 on 1. So this should be brought and kept on the 1. This becomes 2. This third is brought and placed like this. 3. Similarly 4, etc. We want to calculate what is the total work done in arranging all the 10 blocks one over the other. So instead of calculating individually, let us imagine we have n blocks. Generalize the case. Each one has mass m and the side is L. They are all scattered on the ground. What is the work done in rolling them and bringing them to form on a line? Let us imagine all are brought and placed to form the line. Like this, n blocks are arranged. 1, 2, 3, 4, 5, etc. This is the nth block. So all the blocks scattered on the ground are brought together and formed on a line. Now I can imagine this is a single block or a single rod. I want to lift this rod. Let us take this rod is lifted vertically up so that it gets the shape like this. It is lifted, total lifting. Second, third, etc. This is my nth one. So instead of imagining one by one it is placed, second is placed on 1, third is placed on 1, 2, 4 is placed on 3, etc. I am taking the lifting of the total rod. The rod is this one and it is lifted, made vertical. So a bar lying like this is imagined to be lifted like this. And we are calculating what is the work done. Now let us take what is the initial mass. The total mass of the arrangement, since each has m and n balls are present, n blocks are present, total mass is nm. What is the initial height of center of mass? If L is the side, the height of center of mass initial, if I call h1, the h1 becomes equal to L by 2. Once it is lifted vertically upwards, the total height is NL. Now, if I take the height of the center of mass as h2 from the ground, then the h2 becomes equal to NL by 2. Because total height is, this is NL. So, center of mass height is NL by 2 from the ground. So, this is L by 2. Therefore, work done W is given by mg into h2 minus h1. M is n into small m. G into NL by 2 minus L by 2. Take L by 2 common. So, mgl into n into n minus 1 by 2. In general, the work done to place n blocks, each of mass m and side L on one over the other. These are all identical blocks. So, W becomes equal to n into n minus 1 by 2 into mgl. In the present case, n is 10, m is 200, mass. So, let us calculate W. N into n minus 1 by 2 of mgl. N is 10, 10 minus 1 is 9 by 2. Mass 200 gram, 200 by 1000. G10 and length side is 40 centimeter, 40 by 100. Now simplification. 200 5 times 0 0, this 0 gets cancelled. With 2 it is 2 times 4, 5 it is 2 times. Therefore the value remaining 2 into 9, 18 into 2, so answer is 36 joule. The total work done in keeping the 10 blacks 1 over the scattered blacks on the ground 1 over the other, n in 10 minus 1 by 2 into mgl, simplification gives 36 joule. 36 joule is the total work done.